unless you were under a rock the last few days, you probably have noticed, especially yesterday, that you had kind of a crash where Nvidia stock that dumped about $20 and lost about 600 billion dollars in evaluation. Um, and basically, everyone attributed this to the Deepseek and their advances, and lots of people freaked out. And for those of us who were a little bit more aware of what was happening, it's kind of a surprise because you look at the DeepSeek paper. It came out a week ago, and so the surprise was why this happened yesterday. So my guess would be that a lot of reporters were busy trying to interpret Melania's hat, or who was George Bush winking at, or why this president sat next to the other president, or why this CEO was behind, the tribune or whatever. So I basically yesterday can't believe how many DeepSeek YouTube videos were out there and how much people were viewing, and I figured I want to kind of understand this. I did spend a lot of time watching a lot of them, the ones that were at least more technical, and I kind of sat down today with ChatGPT and other things and tried to explain what was happening. So I kind of thought that how about I make my own videos trying to explain this from a technical perspective based on my knowledge of hardware and a little bit of what I can understand from machine learning. And in the process, because I have been also spending some time with OWASP LLM and reading a little bit about the NIST adversarial machine learning papers, I sort of going through this, I realized that there are some things to be said about the security as well. So I kind of move over here to this Google YouTube video. Hopefully you enjoy it. And I was trying to sort of show the Pac-Man eating the DeepSeek, and sort of in my extremely challenged, graphically challenged drawing, show that there are a lot of security issues that you should be considering. So let's start with why this was a big deal. Obviously, the paper said that they released an open source this set of distilled model to the public. So the model became public. They're open source, which was kind of not something people are expecting from China or from the current environment. Although Meta has open source Llama a while back. But as you can see in their announcement, they did use Alibaba. So it's not like China has been years and years behind all this. The other thing that was very surprising that kind of led to Nvidia's crash was that they stated the training cost was just a few million. And I think I was trying to go and crack that and see why it was so cheap and what happened. And the happy thing about this is obviously this is a good step towards democratization of model development. You don't have to be Meta and spending billions and billions on model development. Um, the other thing that I also heard is Andreessen, the venture capital firm from Silicon Valley, said that this is a Sputnik moment. I guess that people feel like now they have to send an AI rocket to the moon or to Mars. Uh, and to some extent, if you listen to people like Perplexity CEO, there were a lot of lessons here that came from their paper and research. And at the same time, to me, it's kind of a little bit of ironic that this whole idea of if you're smart, and you use a lot of nice design features. This reminds me of the NASA space pen that they spend so much time designing to be able to write in space, and the Russians use pencils. So it's kind of I can't resist that analogy right now. So some of the money saving tricks that I'm going to talk about here based on my learning, and a lot of my learning was simply just sitting with ChatGPT all day long and trying to understand different concepts, or you know, reading here and there. So I'm not talking as a machine learning or AI expert with decades of experience, but in the process I try to put my knowledge of networking and hardware and math in use. And at the end, I think I also came up with some conclusions about security, which is one of the big purposes of this talk. So I'm going to go through these money saving tricks a little bit one by one. So the first thing is, what is the advantage of training a model sorry, training a model using another model that just use ChatGPT generated data. And so, number one is that you don't need a lot of raw data. You don't need raw model training, which means you don't need a lot of massive amount of books and web data and Wikipedia. So obviously that means you save a lot of memory, data pipeline cost, GPUs and CPUs and infrastructure for training data. You don't burn a lot of fuel to cool the data center, all that stuff. And ChatGPT says that they use thousands of the expensive NVIDIA GPUs, the A100s, for months to train it. The other thing is when you train the model with another LLM, you're not really learning the language and reasoning patterns from the scratch. Like things that ChatGPT need to learn, like grammar, sentence structure, putting words together, sequencing sentences in a message, punctuation, um, just to write things, and then response patterns. You ask the model is asked a question and it responds with a yes or no or some answer, and then explains the answer, why this answer is the way it is, and then follow with some examples. In my case, ChatGPT knows that I always want, when I'm comparing things, I want a table with the columns describing the two things that I'm comparing with, and rows with all the features that are used in comparison. So a lot of these things is sort of the response patterns that was already there in the big LLM that was used for training. Multi-step reasoning is another thing. Conversational pattern, like somebody would say, when I talk to ChatGPT, it knows that I'm talking about cybersecurity. But somebody says security, ChatGPT would maybe say, do you mean cybersecurity? Do you mean physical security? Do you mean financial security? So, sort of conversational patterns in multiple steps, which means somebody asks a question, the model asks back for some question for clarification, and then remember the context, remember the previous question and answers to be able to satisfy the user. And the politeness was something I didn't think about, and ChatGPT pointed that to me. It's like, you don't tell a user you're wrong. You just say, yes, but there is another way to look at this. A lot of these things are complex patterns that existed in the original LLM, which is basically sort of the concept of um, what was referred to as knowledge distillation. So here, knowledge distillation means you have a bigger model that's called the teacher model that is has a lot more parameters as a sort of a neural network with billions of parameters and weights and gradients and things to make the model, um, do what it's supposed to do with less error and more precision. So obviously, this bigger model is a lot more expensive to train, and it's very capable. Um, and but the smaller model, this guy called the student model, it has a lot less parameter. It's a lot cheaper, um, but it's also very capable. So kind of think about it. If this student um, is a student that went to a private expensive school in a very aggressive charter, and if this student was not going to school or was going to a bad school with bad, absent teachers, obviously he wouldn't learn as fast, so he wouldn't be able to perform as much. um, so it's kind of like think about an athlete that has an previous Olympic athlete as a trainer. Obviously, they're gonna progress a lot faster. Um, and so one example that was given was, how you. I asked ChatGPT, how does this distillation work? So one component is like when the student model is trained, it asks the teacher model some question. Let's say, what's the capital of France? The answer is not just Paris. It's a list of cities with different probabilities. Which one is more likely to be the answer? And so that the student will kind of learn the relationship between these cities. It learns the distribution of various likely classes of cities. You notice is not like Sydney or Beijing in there, but at the same time it provides a set of relationship here. So it's kind of like teaching the student to fish as opposed to just giving him a fish. um, and So basically, as you can see, knowledge distillation would be that if you didn't use this whole teacher student pattern, if you had a smaller model with a smaller set of parameter and you kind of used what they call here reinforcement learning, it would struggle to find sophisticated patterns, whether it's reasoning patterns or other things. But a bigger model with a lot of parameters, there are a lot of different paths that it can follow as far as pattern goes. And so you use knowledge distillation to sort of pass that reason. It's kind of like I remember talking to the kids when you go to the doctor, teach them how to talk to the doctor as opposed to give the answers to the doctor. So it's like kind of like teaching the kids to follow a pattern. How do you talk to a doctor? How do you talk about your symptoms and things like that? So it's kind of similar to this. So you don't need a very extensive um, reinforcement learning training. So it's like you learn not to uh, skip big symptoms to the doctor, so you go through a wrong surgery, for instance. Um, Basically, the other aspect, aside from knowledge distillation, that was used for cost saving, was also mentioned was avoiding human in the reinforcement learning. So what is that? So GPT used or OpenAI used a lot of humans for the reinforcement learning. So what does that mean with this thing called reinforcement learning for human feedback? It's like the model, the language model, provides a bunch of responses, several responses in the two users question, and these human annotators were kind of making, I don't know, $20, $30 an hour sitting and ranking the responses. And then a reward model, a mathematical model, is trained based on that user feedback to start predicting what humans like in terms of their preferences to answers, right? That's how they train the model. Obviously, this is very costly. But if, let's say, you use another model instead of humans to provide reinforcement, that would be reinforcement learning with AI feedback. And this is something right out of ChatGPT. I screenshotted it, and they were kind of showing the labor cost, and they're claiming that there's a huge cost saving here, maybe a factor 5 to 10, um, basically in saving with reinforcement learning. The other lessons here was, the fine tuning. If you're talking about a model like ChatGPT, it was a language model, but it's not, let's say, trained to do very well in reading and interpreting a legal document or a medical diagnosis or a cybersecurity CVE record. So you have to fine tune it, and fine tuning a big model is pretty expensive. But if you fine tune just a set of parameters, which they call low rank adaptation, that will be a lot cheaper. It will save a lot of memory and computation. The other thing is quantization, and this is something that NVIDIA actually enabled this in the latest GPUs, which basically what they call mixed precision, which means when you're representing any value in your model, whether it is an activation or a weight or a gradient or whatever, this will be done in a floating point value with, say, a number of digits. So if, let's say, you use 16 or 32-bit digits, or even 64 bits for your values, you have to store a lot of data. You have to use a lot of memory to store the data, and you have to access it, and you have to use a lot of computation because now you're doing it with a lot more precision. So this costs a lot of money. But when you lower the precision, you can use cheaper GPUs, and this is what they did at Deepseek. But it wasn't just that. It wasn't just using lower precision to save money. According to Perplexity CEO in an interview, he said that they were very clever in, selectively, depending on what they were doing, choose lower precision or higher precision. And this is the sort of lesson that he thought even people in US could learn from. NVIDIA previously referred to using lower precision or mixed precision in inferencing, but people think that you could use lower precision in inferencing than in training. But either way, quantization as a way of saving data size for both GPU and computation is is a um, is a big cost saving measure here. Now, coming to security, like, I looked at all of this, and I looked at the LLM, and based on my reading of the adversarial attack, I kind of thought there's some things to think about in terms of security. The number one thing is prompt injection. If you look at the LLM, OWASP LLM, every time I go and download the OWASP LLM, in every few months it's changing. It's changing so fast, but prompt injection is always there. So that is basically somebody writing a prompt to the language model, and in the middle of the prompt, they may put something in there. Or now they're getting sophisticated. Maybe somebody submits a PDF or an image or something, and then in the middle of that PDF or an image, there may be some script that the LLM is going to execute. So I feel that this, if you have a large language model, a teacher model that has prompt injection weakness, obviously the student model is going to inherit that weakness, and it's going to probably get worse. So I think, especially with this movement of having open source model, these open source models are going to be, cross-site scripting heavens for all kinds of injection attacks for for the models through the prompts. The NIST adversarial paper talks about evasion attacks, and this is where an attacker has access to the model input and output and gradually starts feeding sort of data in a way that slowly it makes the model make the wrong decision. Let's say it's a self-driving car and trying to detect things, and it takes a stop sign, and instead of interpreting a stop sign, it interpreted at like a speed limit 30 mile an hour, and that's obviously not great. So these are evasion attacks have been talked about as adversarial attacks, and obviously an open source model where everything about the model as far as parameters and various structure, when they're open, it's anyone in a security knows that that would be a white box attack, and it's worse than a black box attack because you know what you're attacking and how you can craft evasion. And so this is going to get worse when you start having a lot more open source stuff here. And I also think this gets worse when you use this teacher student model. And I think my prediction is that today they talk about using adversarial training, provide adversarial data in the training so that you add model robustness towards adversarial attacks. I think the student who just learned from a teacher might be too spoiled. I'm just using real life analogy, and thinking probably will be too sensitive to adversarial attacks. And unless the knowledge transfer from teacher to student is somehow distilled with knowledge of adversarial robustness, it's going to the student is probably going to be more sensitive than the teacher to adversarial attacks. Model theft is an important LLM attack, but it's not obviously an issue here because the model is not a secret. Um, so from MLOps perspective, thinking about, let's say just typical software development lifecycle security, you need to safeguard your code on GitHub or wherever it is. Make sure there's access control. Make sure there's a registry where good code can be downloaded and deployed. Those things um, may not be an issue here, but obviously where you get the model and how much you trust it, and looking at the provenance and the pedigree of the attack, the model is the same as picking open source from GitHub. You want to make sure that the model has a lot of people contributing to it. There's the bugs are fixed and stuff like that. So typical software security when it relates to open source here applies. I think a lot of the regular data pipeline and infrastructure security issues apply here. The same way you have to protect your GPU to CPU, your GPU to memory, your CI/CD pipeline, where your data comes from, from the outside, or how the data is managed inside. They talk about data lake house now. Databrick talks about data lake house. And by the way, on MLOps, I forgot to mention Snowflake and Databricks. They both provide, access control and RBAC and lots of other things to different parts of the infrastructure. So those things still apply. This is very similar things that DevSecOps deal with. It applies here. Um, the other thing is with the one model is being trained by another model, any bias or hallucination issue in the teacher is going to just go over to the student. And then privacy. If you're giving your data to ChatGPT today, a lot of people running ChatGPT to enterprise and are worried about people in the company putting code or legal documents or business documents into ChatGPT. this the same thing here applies. But I think I'm not trying to be political here, but this is a model from China, and if you had issues with TikTok, there would be definitely pretty soon. I think people are still trying to digest what happened yesterday, but pretty soon they're gonna say something. I just heard the Navy or some military complex banned use of Deepseek just today or yesterday. So this is gonna happen. Yes, there is issue with China and models from China, but it's going to be in general privacy is something you have to think about. I'm sorry. So in summary, you will inherit a lot of the teacher's weakness, model weaknesses, and sometimes worse. You may lose a lot of teacher model strengths and robustness unless you do a good distillation of the model in terms of robustness and adversarial training. And there's still a lot of LLM and MLOps security issues apply here. And like I said, a lot worse. So there's something to think about as this wave of open source and using a big model to train a small model is gonna catch on for sure. Especially because a lot of people now are busy developing agents and applications, and already people yesterday were talking about, yes, now we know the money is in application and not in the model development or maybe infrastructure. So that's the end of this. And again, I'm here. I will provide the contacts, and this is here for providing support and consulting on security, all matters of security, from architecture to cloud security, application security, and all of that. So thanks, and hope you enjoyed this talk, and please subscribe for future videos. Thank you. Bye bye.